Now we are going to learn about the merge sorting algorithm. So it is a divide and conquer algorithm. So what happens is first we divide the given array into smaller subarrays such that each subarray is going to have a single element only. So when we have the single element, we know that an array with single element is always sorted. So what we are going to do is we are going to merge sorted arrays. So here we have 5 1 4 2 8. Each one is a subarray with size 1. So 5 and 1 is merged, so we get 1 5, and here 2 8 is merged, so we get 2 8. Now with this array 2 8, 4 is getting merged, so we get 1 4 5, and sorry, this is wrong. So we are actually merging 1 with 4 and 5. 1 5 is getting merged with 4, so it is 1 4 5, and 2 8 is getting merged with 2 8. So then what happens is 1 4 5 is getting merged with 2 8, so it becomes 1 2 4 5 8. So these sorted arrays, they are getting merged together, and then we are getting the final answer. Okay, so what we are going to do is that when we will be merging these sorted arrays, we will be making use of a temporary array. Why? Because we do not want to make changes in place while before this thing is done. Before those elements they are placed at their correct position, we don't want to make changes to them. We are using a temporary array where we'll be inserting elements such that those elements are in the position where they should be in the original sorted array. Okay, so let's just start writing code for this algorithm. So merge sort, what we are going to do, we are going to make use of the merge sort function, and this function is going to take three different parameters. Okay, so firstly we are getting the length of the nums array, and the merge sort algorithm, it will take the nums array, and the starting point is 0 and the ending point is n minus 1. Ending point is the last element, starting point is the first element index. Okay, so let's define the merge sort function. So nums and low and high are the pointers. So if low is greater than equals to high, so what this means is if there is only single element or an empty list, in that case what we are going to do, we are going to just return. Okay, so otherwise what we are going to do, we are going to find the middle element index. So low plus high divided by 2 is going to give us the index for the middle element. So what we are going to do now, we are going to recursively divide this into two subarrays. The first one is going to be starting from low till mid, and the second one is going to be starting from mid plus 1 till the high. Okay, so let me also put the self keyword over here. So once we are done with these recursive calls, the base case will hit, right? And the base case, when it will hit, that means we will only have single elements, and those single element lists are going to be sorted. Since any list with single element, they are always sorted, and we are going to merge those sorted arrays, and those arrays will be merged such that the resulting array is also sorted. So let me give the nums array, and then we have the low, mid and high. We are providing low, mid and high pointers. Why? Because we want to know that these three variables will give us the position for the low and high pointers for those two arrays. The first one will start from low till mid, and the second will start from mid plus 1 till high. So let's also implement the merge method. So low, mid and high, these are the methods. So we will make use of some pointers. The first pointer is going to traverse through the first sorted array, so it will start from low, and the second pointer, which is going to traverse through the second sorted array, it is going to start from mid plus 1, because the starting of the second sub array, it is from mid plus 1. Now we are also going to have one another variable k, and what it is doing is basically we are going to have a temporary subarray where we'll be storing our temporary sorted list, a sorted list which is basically the combination of two sorted lists. So let's make it an empty array, and whenever we are calling this sort array function, what we need to do is basically we are going to set the size of this to n, right, which is the size of the input array itself. And also the sort array, this method is going to return the nums. So now what we are going to do is basically within the sort function we have to compare the elements, and we want to compare them while keeping in mind that the low should be less than equals to mid. Not low, actually the I should be less than equals to mid. We are only going to traverse the ith pointer, which is going to be the pointer for the first subarray till mid, because the first one subarray is from low till mid, and the j pointer, it should be less than equals to end. Now we are going to compare if nums of I is less than nums of j. In this case, what is going to happen is basically within the temp array, we are going to store the element from nums of I because they are smaller, right? So this is equals to nums of I. And after storing, now we have to move forward. So I plus equals to 1 and k plus equals to 1, since we have placed the element. Now similarly, if the reverse is true, meaning if the nums j is a smaller one, then we are going to pick it from nums of j, and then we have to move forward with the j pointer. What can happen is that if one of these conditions is met, then this loop will break, meaning we have traversed through one array. Either this is true or this is true. Sorry, either this is wrong or this one is wrong. So either the first one we have fully traversed, or the second one we have fully traversed. In that case, we also have to check that if I is less than equals to mid, meaning if we have not traversed the first array, what we need to do is we need to set the element from the nums of I and move forward. Similarly, what we have to do is we have to check for the second array as well. If we haven't traversed the second array, this is actually high. Okay, so if we haven't traversed the second array, then what we are going to do is we are going to pick the elements from the second array, right? So now finally we are done with merging all the elements from the first array and second array within the temp array. And since we have merged the elements within the temp array, now what we are going to do is basically we are going to look for the all the elements that we have arranged in the temp array. So from low till end, we want to also include the end. What we are going to do is the self.temp I, which means the element is at its correct position. So we are going to set this into the nums array itself. Within the nums array, we are positioning these elements at their correct position. Okay, so now the solution is we have first calling the merge sort algorithm on this nums array with the starting and ending index, and we are also making use of this temp array within the merge function. Here we are using the merge sort function. The merge sort function, what it does is basically it has a base case that checks if there is single element or an empty list. In that case, we are going to just return and else what we are going to do is we are going to find the middle element index, and then we are going to partition it into two parts based upon the middle element. Okay, so from low to till mid is the first part, and from mid plus 1 to high is the second part. And then what we are going to do is finally we are going to merge these two arrays, right? So we have provided the pointers which are low, mid and high to the merge functionality. Okay, so the merge functionality, we are keeping these different pointers so that we can traverse through the first and second sorted sub arrays, so that we can merge them together into the temp array first. So the k, which is the index for the temp sub array, I is the index for the first part of the sorted array, and the j is for the second part of the sorted array which we want to merge. So while I is less than equals to mid, which is the ending point of the first sub array, and j is less than equals to high, which is the ending point of sub array, we are comparing those elements. So if the element from the nums of I, which means from the first part, is smaller, then set it into the temp variable. And if the element from the j point, pointer pointing at, which means the second subarray is smaller, then set it to nums of j, right? And then we are checking if we have traversed all the elements from the first subarray or not. If not, then place those elements. Okay, similarly we are checking if we have traversed all the elements from the second subarray or not. If not, let's place all those elements. And in the end, what we are doing is, now we have the answer, the sorted subarrays within the temp, but we want them into nums subarray, right? So what we are going to do is, we are going to traversing from low till the end, and then we are placing it into the nums of I. Okay, so let me submit the solution. First, let's run. Okay, the merge take 4 positional arguments, but 5 were given. Okay, so let's see what is the issue. Low, mid, and high merge. Okay, sub dot merge low, mid, and high. Sub dot merge nums low, mid, high. Okay, so now it's corrected. List assignment out of index error. Sub dot k self dot temp k is equals to nums of j if I is less than equals to mid and j is less than equals to high. So I plus equals to 1, j equals to 1. Self dot temp k list assignment out of index error. I is low, j is mid plus 1, k is also low. Why I'm getting this error? I merge sort mid plus 1. Let's see, minus 1 into n is the size of this. The merge sort is called from 0 till n minus 1. Okay, so actually I have found the issue. The issue is this is not actually the and, this is I, and it should have given me a wrong syntax error, but it haven't. So, and another issue is, actually this is a silly mistake. I actually forgot to provide the self keyword over here, right? So the temp is never actually getting initialized here when we are using it. So that is why we are getting the list index out of bound error. Okay, let me just run this code. And if I submit the code, yeah, so it is getting accepted. So this algorithm, it has a recursive calls for the merge sort algorithm, and each time we are dividing the array into two different arrays of equal size. So it is, each array is getting divided into size of n by 2. So the depth of this array is log n, because each time we are dividing this element into size 2 until we get size 1, we are dividing by 2. And the merge function, it works in big O of n time complexity, and therefore we have the time complexity for this whole algorithm is n log n. And here you can see that we have the temp array, which is of size n, where n is the size of the input array itself. So it works in a space complexity of big O of n.